Okay, everybody, here we go. Take a few notes today. Hope you're having a great day and doing well. You need to complete these notes and bring them to class with you the next time we have class. So I'm going to start, I know some classes have already done for G and H, but I'm going to start with that. So on page 35 of our notes, this is 4G, cotangent 500. And what we're going to do is, we're going to recognize that 500 is more than one time around. So I'm going to go all the way around once. That would be 360. And then I have to go some more. How much more do I have to go? I have to go 140 more. Because 500 minus 360 leaves me with an extra 140. So there's all the way around. And then here is 140 degrees over here in this quadrant. So 500 is more than a revolution. So I go all the way around, that's a revolution, that's 360. And then I'm going to go for 140 more, which puts me in quadrant 2, which means this is negative, this is positive, and my hypotenuse is always positive. This is my angle that I look at. Always with my butterfly bow tie, I am looking at this angle right here, always, always, always. And I want the cotangent. So cotangent is adjacent over opposite. So that will be negative over positive, which is negative. So the answer to G is negative. Secant, negative pi over 7. Well, I don't know what pi over 7 is, so 180 divided by 7, that's negative 25. So this is like the secant of negative 25 degrees. So think about your setup, and remember that when an angle is negative, it still starts here, but it goes down. So if I'm only going down 25, I'm here, because all the way to here would be 90. That's negative 90. So I'm only going to 25, so I'm in here somewhere. There's my triangle. Opposite is negative, adjacent is positive, and of course the hypotenuse is positive. I want secant. Secant is reciprocal of cosine, so it's hypotenuse over adjacent, which is positive over positive. So the secant, positive over positive, will be positive. All right, now we're going to do the really cool stuff. I do circles for a couple of these, and actually I'm not quite sure why. Please ignore the circles in the notes. We have just been drawing butterfly bow ties, and I think that's the best thing to do. So here's how we're going to do the sine of 150. Do not let my circles confuse you. Luckily, I only did it twice. Okay, here we go. 150 degrees. I have to figure out where 150 degrees is. So remember your setup. Always, always, always. Now where are we going to put 150? Start here. Start marching around. Would you agree that 150 is up here? 150 degrees is up here somewhere, because it's before I get to 180. So I'm going to drop my perpendicular straight down. Now this is 150. This is 90, straight up is 90. Here's 150, here's 180. The key to the problem, guys, is this angle right here. Look where I'm pointing, right there. That's the key to the problem. I'll make it blue. I don't know if you can see the colors or not, but that's blue. How how big is that blue angle? Think about it. If this is 150 and this is 180, then wouldn't the blue angle be 30? Because 150 plus 30 would get you to 180. Or 180 minus 30 would get you to 150, whichever way you want to think about it. Now, across from the 30 is always 1. Across from the 60 is root 3, and the hypotenuse is 2. Yeah, folks, this is one of your special triangles. Be careful, though. This one has to be negative, because look where I am. I'm left and up. To get to my 150, I'm left and up. So this is negative, that's positive, and that's always positive. Now, I want the sign. Sine is opposite over hypotenuse. The answer to the question is 1/2. So without a calculator at all, you found the sine of 150. I know you could type that in on your calculator, but now you have done it by hand. All right, let's try the next one. Tangent negative 240. All right, here we go. First thing I have to do is draw that angle, figure out where it is. Now, be careful, it's a negative. So negative means don't go this way, go this way. So I'm gonna go ahead and put on some negative labels. So this would be negative 90. Remember, a quadrant is 90, a right angle. So this is negative 90. This will be negative 180, negative 270, and then negative 360 if I go all the way around. Negative, that's this way. Now, where is negative 240? Well, I hope you agree that it's past 180, but before 270. So it is in this quadrant right here. Here's negative 240. Past 180, but before 270, so in between there. So I'm going to drop that perpendicular straight down. And here comes the most important piece of the problem. If this is 180, and this is 240, how big is the angle between my fingers? This is 180, this is 240. How far is between them? I hope you're saying 60. That's a 60-degree angle, because 180 plus 60 more gets me to 240. 240 minus 180 is 60. And if that's a 60, this is a root 3, this is a 1, this is a 2, and that one's negative. Because if I am on the left side of the origin, I'm negative. 60 across from root 3, 30 across from 1. Now I want tangent. What's tangent? By definition, tangent is opposite over adjacent. So root 3 over negative 1, that is negative root 3. And that is the exact tangent of negative 240. Alrighty? Now, I'm not sure, but probably the first thing you'll want to do with this is change it into degrees. So 5 times 180 divided by 4. So that is the tangent of 225. 225 degrees. Next step, draw 225. So you know what your setup is. This is a positive angle. So I'm going to go around positive direction. That's up and around. I'm going to figure out where 225 is. Well, hopefully you realize that 225 is between 180 and 270, so it's down here. So my butterfly bow tie triangle, take that perpendicular straight up. This angle is 225. Right there, that's 225. This is 270, that's 180. Now, here's the key again. This, I can't say it enough. This is the key to the whole problem. You need the angle between my fingers. This is the angle right here, the angle at the origin. That's the angle. It's between my two fingers. So this finger is at 180. This finger is at 225. I want to know what's between them. How much is between them? So wouldn't that be 225 minus 180? 45 degrees. Because from 180 to 225 is 45. When you go to find your angle, guys, it's right here. Between my fingers. This angle right here at the origin. 180 to 225, so that's 45, which means we have a 1, 1, root 2. Those have to be memorized. We talked about that. But be careful, look where you are. Aren't the ones both negative this time? Because we are in quadrant 3. So negative, negative. Tangent. This is my angle, opposite, adjacent. So tangent's going to be -1 over -1. So the answer to the question is 1. The tangent of 225 is 1. This is really important stuff. I hope you're sort of getting it a little bit. Cosecant 3 pi over 4. So what do you think I'm going to do first here? If I'm going to find the cosecant of 3 pi over 4. I hope you're saying, I wish you were here, I hope you're saying 3 times 180 divided by 4. So that will be 135. Now, here's your setup. And you got to figure out where to put 135. Remember, we start here, just move around, so here we go. Looks like I'm going to put it right here. That's 135. Here's 90, 135, 180. And when I drop that perpendicular, which angle is the important one? Always the one at the origin. And what is it between? It is between 135 and 180. How many degrees are between 135 and 180? I hope you're saying 45. So we have our 1, 1, root 2 triangle. And this time, the only negative is right there. We went left and up, so that one's negative. Now, we want cosecant. Cosecant is the reciprocal of the sine. So sine is opposite over hypotenuse. So this is going to be hypotenuse over opposite. So that will be root 2 over 1, hypotenuse, opposite. So the answer to the question is just root 2. Couple more. 7 pi over 6. Probably want to change that into degrees. So the sine of 7 pi over 6, 7 times 180 divided by 6, so that's 210. 210 degrees. So the next thing we need to do is draw it. So we know what our setup is, our framework. We're going to draw 210 degrees, always starting here now, going up and around. So 210 would be down here. Would you agree with that? Here's 180, here's 270, so 210 is going to be somewhere in between. Past 180, before 270. I'm going to drop my perpendicular straight up to the x-axis, and this is the angle that matters. It's the angle between 180 and 210. What is the angle between 180 and 210? 30. Now, I know there's a 270 in here. I know I know all those other numbers are in there. This is the angle I want. The angle right there at the origin. That's the one I want. And it's made by 180 and 210. Nothing else is part of it. So ignore the rest of the numbers. Well, across from the 30 is 1, root 3, 2. Because I am in quadrant 3, these are both negative. I want the sign. Sine is opposite over hypotenuse. So the answer is negative 1/2. Finally, cotangent 5 pi over 3. So you know at this point that you need to change that into degrees. So that's cotangent 5 times 180 over 3, 300 degrees. Now you're going to draw 300 on your framework. And this time it's going to be down here because 300 comes between 270 and 360. Remember, we're going around, starting here, going around. So perpendicular, straight up, making your butterfly bow tie. And now this is the angle that we care about. My blue marker is 300, my black marker is 360. What is the angle between those two markers? 60 degrees. So this is a root 3, this is a 1, that's a 2, and the negative is on the root 3. We went right, that's positive, but we went down, that's negative. Cotangent. Adjacent over opposite. So 1 over negative root 3. That's negative root 3 over 3. That is the answer to the question. All right. Now we got some more problems, and they're kind of the same. And this time I use circles, and there's a good reason for the circles. Where the first problem A, 6A, deals with 90 degrees. Where is 90 degrees? 90 degrees, if you look at your setup, 90 degrees is right here. And that is on an axis. And when it's on an axis, we can't make a triangle, we have to make a circle. So this is my angle right here. Now, they didn't give me a point. When I did these before, I had a point. I do not have a point. However, if I just arbitrarily say, I'm going to let my radius be 1. Trust me, you're allowed to do that. In fact, you're allowed to make the radius anything you want it to be. But the easiest number in the whole wide world to work with is 1. So I'm going to make the radius 1. Okay? Now, if the radius of the circle is 1, then this point is the point 0, 1. I'm going to erase my 9 because I don't want you to get confused there. If the radius is 1, here's the origin, I'm going up 1. So that's the point 0, 1. So x is 0, y is 1, and r is 1. I made this up, but I'm allowed to do that. I can make anything at 1. Please, just make it 1. That's the easiest. Now I want the sine and the cosine and the tangent of that angle. So consult your purple sheet. You need the circular definitions. Sine is not opposite over hypotenuse unless you got a triangle. We don't have a triangle. So sine is y over r. Y over r, 1 over 1. That's 1. Cosine is x over r. 0 over 1, that's 0. And tangent is y over x, that's 1 over 0, which is undefined. Done. It's that easy. Next one is negative 180. So I'm going to draw negative 180. Where is the angle negative 180? Well, look at your setup here. Negative. Negative means I go down. So 0, this is negative 90. Here is negative 180, right here. So on my circle, I'm right here. Now, I don't know how big that circle is. We get to make it up, so we're going to say the radius is 1. Now, if the radius of the circle is 1, that means I'm going 1 in every direction. So if I go 1 in this direction, to get to this angle right here, if I go back 1, then this point is negative 1, 0. So x is negative 1 and y is 0. Okay. Sine is y over r, 0 over 1, which is 0. Cosine is x over r, negative 1 over 1, or negative 1. And tangent is y over x, which is 0 over negative 1, which is 0. So there are the answers for the sine, cosine, and tangent of negative 180. All right, next one. What is 3 pi over 2? 3 pi over 2, that's 3 times 180 divided by 2. So that's 270. Now, where's 270? Well, start here. Up and around. 270 is right here. if you let the radius be 1, and you come straight down, 1, this point is 0, -1. Guys, that's just plotting points. You're coming down 1 unit from the origin. So think of a piece of graph paper. That's 0, -1. So x is 0, y is -1. I'm going to fill them in. Sine is y over r. Y over r, -1 over 1, -1. Cosine is x over r. 0 over 1, 0. And tangent is y over x. These are on your purple sheet. Tangent is y over x, which is -1 over 0, which is undefined. You can't have a 0 in the bottom. Every time you have a 0 in the bottom, it's undefined. And then the last one, the angle is 0. Well, here's our framework. Where is 0? It's right here. This is the starting point. This is 0 right here. This angle right here is 0. So if the radius is 1, what will that point be? You're starting at the origin and going over 1. So what is this point right here? 1, 0. So x is 1, y is 0. X is 1, y is 0 on that point right there. If that's the order. Sine y over r. 0 over 1, 0. Cosine x over r. 1 over 1, 1. And tangent y over x, which is 0 over 1 or 0. Beautiful, beautiful, beautiful. All right, we're going to do one more problem, and this one is going to be a challenge. All right, we're going to have to keep track of a lot of stuff, but I'm confident that we can do it. Okay. So here we go. We are told that the cosine is 2/3 and the tangent is negative. That went off the page a little bit. It's less than 0. So this means the tangent is negative. It's less than 0. Now the tricky part about this is, I mean, ultimately you're going to find the sine and the cotangent. And that part is not hard. You know how to find sines and you know how to find cotangents. That part is not hard. What makes this tricky is you have to do some real problem solving to figure out which quadrant it's in. So here's what's going through your head. I have a triangle here, and I don't want to confuse you, but we have to look at all of these. We have to figure out which one it is. I know that the hypotenuses are always positive. Those are always positive. This right here is positive. This right here is negative. This and this are positive, and this are negative. So basically what I just did was draw my entire butterfly bow tie and then label all of the sides with positives or negatives depending on the quadrant I was in. So right is positive, left is negative. Up is positive, down is negative. Now, I need the cosine to be positive, positive. Now, cosine is adjacent over hypotenuse. So if you looked at this triangle right here, adjacent over hypotenuse would be positive. So this could be 2, and this could be 3, and that would work. The cosine is 2 over 3. You could do your Pythagorean theorem, 2 squared plus b squared equals 3 squared, just like we've done before, and you would get this to be the square root of 5. Perfect. Here's the problem. If you found the tangent of this angle, it would be opposite over adjacent, which is root 5 over 2, which is positive. And according to the problem, the tangent has to be negative. So this is not the right place. It seemed good, seemed like it was going to work, but it doesn't. So then you got to look further. We need adjacent to be 2 and hypotenuse to be 3. So what if we look down here? What if we looked at this triangle? Is adjacent still 2 and hypotenuse still 3? Yes. And this would still be root 5, except it would have to be negative because it's going down. It's still root 5 because it's still the same Pythagorean theorem. This is where you need to be. This is the triangle that we're talking about, because that is the triangle that has a positive 2 adjacent, a positive 3 hypotenuse, and a negative opposite, so that when you do opposite over adjacent, it turns out negative like it's supposed to. All right, looking at that triangle right there, what's the sign? The sign is opposite over hypotenuse, negative root 5 over 3. The cotangent is adjacent over opposite, so 2 over negative root 5, or negative 2 root 5 over 5. If you bring the radical up and make this a plane 5 on the bottom. Done. Now that's a lot to think about. Couple more. When I said we had one more to do, I meant one more part to do. All right, B. Hang in there. I know it's tricky, and I know you're probably getting bored, but come on. You've been hanging out all day. You can do this. All right, so what do we know? We know the sine is a positive 1/5, and we know the cosine is negative. So I want you to think about all your triangles. These are all positive. All the hypotenuses are positive. The ups are positive. The downs are negative. The rights are positive, and the lefts are negative. Now, you want the sign to be positive. So in other words, you want opposite to be 1 and hypotenuse to be 5. Now you can do the Pythagorean theorem to find this side right here. You have a 1 and a 5. So 1 squared plus b squared is 5 squared. So 1 plus b squared is 25. B squared is 24. And the square root of 24 actually breaks down into 2 root 6. So right here would be 2 root 6. would be perfect, except this says the cosine is negative. Less than 0 means negative. Is the cosine negative? No. Adjacent over hypotenuse is positive. So that triangle won't work. That won't work. So where do I need to look? Well, remember, you still need opposite and hypotenuse to be positive. Opposite and hypotenuse to be positive. Will this triangle be okay? Well, that part works. That's 1/5 for the sine. Here's your angle. This side, same Pythagorean theorem. So this side would be 2√6. But left is negative, so now it's negative 2√6. That's your triangle, folks. That is the triangle right there where sine is 1/5 and cosine is negative. Adjacent over hypotenuse will be negative. So what are we trying to find this time? We want the secant and tangent. So this is your triangle. I'll get these pluses out of here. That's a little confusing maybe. Okay, so that's 1, that's 5, that's negative 2√6. Okay, so the secant is the reciprocal of the cosine. So it's going to be hypotenuse over adjacent. So that's 5 over negative 2√6. Now let's not freak out about this. The √6 is going to have to go to the top. And then on the bottom, I'm going to have a plane 6. So my bottom is negative 12. 2 times 6. Because when I multiply top and bottom by √6, this makes a 6 times 2 makes 12. There's your secant. Tangent, same thing. 1 over negative 2√6. Get rid of that √6. So we have √6 over negative 12. These two make a plane 6, and 6 times 2 is negative 12. All right, one more, you guys. One more. And then your 4.3 homework will be due. All right? In 2 days. So I guess tomorrow, so this will be due on Friday. 4.3 is due Friday. All right, here we go. We know cosine is negative 3/5, and we know tangent is positive. So we got to figure out where that is. So here's my butterfly bow tie. I know these are all positive. I know right is positive, left is negative. Ups are positives, downs are negative. Cosine is negative. Now remember, cosine is adjacent over hypotenuse. Hypotenuse is always positive. So we need the adjacent to be negative. Aren't we over here? Isn't this where it's negative 3 over here? And the hypotenuse is 5. So I am one of these two triangles. I'm either this one up here, negative 3 over 5, or this one here, negative 3 over 5. Now I need the tangent to be positive. Well, tangent is opposite over adjacent. So if I put opposite over adjacent in this triangle, would that be positive? No, that would be negative. How about down here? If I put opposite over adjacent, that's negative over negative, would that be positive? Yes, it sure would be. So this is my triangle right here. Now what am I missing? Well, Well, I am missing my opposite side, so I'll do my Pythagorean theorem. 3 squared plus b squared is 5 squared. So 9 plus b squared is 25. B squared is 16, so b is 4. So this is negative 4. What do I want? I want the tangent and the cosecant. Well, this one's a lot easier than the last one. Tangent is opposite over adjacent, so that'll be 4 over 3. It's negative 4 over negative 3. And then cosecant is the reciprocal of the sign. So it will be hypotenuse over opposite. So 5 over negative 4. Man, I know those are tricky, guys. That's probably the hardest kind of problem in this chapter. But you can figure it out. You just have to figure it out. It's some puzzling. Anyhow, thank you very much. Have a wonderful, wonderful day, and I hope to see you very soon.